Would you mind writing this on the board? Would you mind? And right next to volume. The amount of space that matter occupies is called volume. Is my volume different than Jasmine's?
Yes.
Yes. Is this water bottle different than the book?
Yes.
We only know when we can measure it, right? And this is where geometry comes into play. When you're told to figure out the volume of an object shaped like this versus the object or an object shaped like a table. Is it easy to find the volume of a table?
Yeah.
Length times width times depth. This water bottle. You have the handle, you have the lid, you have the cap. Right. Miss Caden's over there going, oh my gosh, that sounds awful. I'm not gonna lie, I thought it was. Do you like geometry?
No.
Okay, so Alex is a big fan himself as well.
It's fun.
Okay? However, I will tell you this is a trick that I never learned until I was in college. Okay? When you have a can and you're trying to find the volume of a can, the most simplistic thing ever is you take your circles, top and bottom, and then imagine that this is you draw a line, so if this is a can of beans or whatever you want it to be, and then you roll that out
That's what Mark did.
to a square. Now you have your length times your width, and then you figure this out, put it all together, and that's the volume of that can. I didn't know that until I was in my early 20s. So keep that in mind for anybody trying to solve the volume of a can. Is this? I have no idea. I had no idea until I was in college. Would somebody read weight for me, please? Jasmine.
Weight is a measure of the force of gravity on an object.
Keep going. The whole paragraph, I'm sorry.
The force of gravity depends on the mass of the planet or moon where the object is being weighed. Because the moon has much less mass than Earth. On the moon you would weigh about 1/6 of what you weigh on Earth. Jupiter has more mass than Earth. On Jupiter you would weigh more than twice what you weigh on Earth.
All right, so there's two things in there. Weight. Would you, Jasmine, come up and write what weight is? So what is weight? How is weight measured? Mr. Wan? How is weight measured? What is weight? So your book, right underneath that yellow highlighted area, where it says weight.
Weight is a measure of the force of gravity on an object.
Just you can write measure of the force of gravity. Okay, so as we've talked about, the moon has more or less gravity pull than Earth. Less? Specifically, and you are going to want to underline or highlight this, specifically how much less. It's right there in that paragraph. Ilya? 1/6. You guys, I promise you will see this again. 100% promise that you will see the difference of gravity from the moon to Earth is 1/6. It's gonna come. Okay? Would somebody read that last paragraph to find the weight of an object? Billy. What's that? Yep, no problem.
Yeah.
To find the weight of an object, you could place it on a scale like the one shown in Figure 2. The object's weight pulls down on mechanisms inside the scale. These mechanisms cause beams or springs inside the scale to move. These movements are calibrated in such a way that the object's weight is displayed on the face of the scale.
All right. So let's take a look at this. Bananas on Earth versus bananas on Jupiter. Okay. Effective gravity on weight. Figure 2. On Earth, the bananas on the scale weigh 2 pounds. If you look back up, what is the difference in weight from Jupiter to the Earth?
Earth, it says you will weigh nearly twice as much.
Nearly twice as much. Now, does that mean exactly twice as much? It just means nearly, around that 2 times. More than twice. Okay? So more than twice. So is 2.5 more than 2? 2 3/4 more than 2? So they're not exactly sure, they just know that it's more than twice. So what do you notice between the Earth and the weight on Earth and the weight on Jupiter? Explain your answer. Talk for about 30 seconds with your table partner, please. Why are they more? That's the other side. Top to top. Okay, so why is the bananas more on Jupiter? What about it? What do you think makes it more? Alright. So read the scale. Eyes back up here, please. Eyes back up. Miss Faith, what the bananas on Earth weigh what, according to the scale in your book? Shh, Jordan. So what is the weight of the scale on Earth? 2 pounds. What do you notice about the weight of them on Jupiter? Roughly. What's that? Less than 5? 4.5 fish, a little more than 4.5? Okay? What's that? They are. So there's another thing. Have you guys ever seen a kitchen scale?
Yep.
Yeah? Alright, eyes up here, please. Back table, eyes up here, please. Mr. Caden. Jordan, up here, please. Alright, so you have, I'm going to draw the top of it. This is what mine looks like. You got a digital readout right here. You've got, I don't remember what the buttons are. Right here, maybe one in the middle. And there's one that says TARE, T-A-R-E. Does anybody know what that means? What does that mean, River? No, it's T-A-R-E. You're thinking T-E-A-R. This is T-A-R-E. Alec, what is TARE? You're setting it at 0. Okay, you set it at 0. Why would it be important to set a scale at 0, Mr. Caden, before you put something on it?
So then you know the true weight of it.
So you know the true weight. Can you get, if you got a piece of dust on here, depending on your scale, could that dust register?
Yeah.
Potentially, right, depending on the sensitivity of your scale. So, with scientific instruments, they're a lot more delicate. So if you get something that gets cast on here, you want to push that TARE button, and it's going to set it to 0. Now you're going to take your bananas, your flour, whatever it's going to be, you set it on here. Right, Jordan?
Yeah.
What did I say, Jordan?
I can't remember.
Cameron, what did I say?
You said that you push the care button when you go to 0.
So that you can measure something else. So what did he just say, Jordan?
I can't hear.
Okay. What did he say, one?
So you gotta set that TARE, get a TARE button to 0.
Set it to 0. So what did you say, Jordan?
Press the button to set it to 0.
Why do we need to set it to 0? You are looking for specifically 3.25 grams. Why do we need to set that to 0, Jordan?
So we know the true weight.
Could that 1 grain of whatever it was, could that change it to 3.26?
Yeah.
Potentially, right? Depending on the sensitivity of it. So let's switch back over to page 14, connected. It says in the fruit market photo, outline 3 things that have mass. So you are going to, you're going to circle if you want anything on those scales, anything that has mass. Did you almost circle the entire picture? Yep. Yeah. Because everything has mass, right?
Even the paper has that.
Even the paper, even the page that's printed on has mass.
Or the granite that's on it.
Yep. Donuts. When you guys grab donuts, those little sheets? I hope you guys use the little sheets to grab your donuts. If not,
There's a little hole to those.
okay, take your donut for me, please. And that's gross. Sample. All right. How much do you think an apple weighs? Write it down. How much do you think an apple weighs?
3.33 pounds.
I have had an
I
apple.
thought we did this yesterday.
Did we do this one? I didn't think we did one yesterday. It wasn't yesterday. We've done something like it.
No, we did this week, that's inside.
Okay. How do you think an object's mass relates to? Okay, yep. I'm sorry, we did. My apologies. All right. 16. Volunteer for triple beam balance scale. River, have you read for me yet? Okay. Voices off, please. Triple beam balance scale. Go for it.
A mechanical scale is like a seesaw. An object of unknown mass put on one side of the scale, and then weighted tags are moved on the other side of the fulcrum until the two sides are in balance. Gravity is acting on both sides with equal force, so it is not a factor in measuring mass this way.
So how is gravity pulling on both sides of that? River?
The tab isn't being moved onto the other side of the scale.
See, this is where I should have went to Mr. Not Coomer, Mr. Bruner. He's a science teacher at high school. Is that right? Okay. I should have brought one of those scales. So how does, looking at that picture, gentlemen, put your chips away. We're not supposed to be eating chips. Put them away. Eli, please put your chips away. So how do we measure this? How does this fulcrum work? How does this scale specifically work?
Oh, it
Let's
uses
see.
balancing to measure.
Right.
Like at the doctor.
Have you guys ever been at a, I don't know if this is a thing. Might age myself a little bit. You guys ever played on a teeter-totter, or you might call it a seesaw?
Yeah.
That's how it works. What happens when you get two people of equal size on opposite sides of each other?
You go up and down.
You balance. It eventually starts to balance.
You balance on what?
If the weight of an object has a smaller mass, but the weight is the same weight as something else that might have a larger mass, is a pound to pound.
Yes.
So it doesn't matter if it's 1 pound brick or a pound of feathers, 1 pound is a pound, right? I don't even have a list for you guys, I'm sorry. Get your books put away, thank you very much. And I'm sorry for those of you who got their stuff cut today. I'm ready. Mr. Allen, appreciate you always. That's what I did. Actually, no, I went like this for Williams. Williams. No.
You mean guys at the Mr. W? That was Mr. Four swings of hand now. That was Mr. Not
Really? So in Florence, as the elementary kids are walking down the hall, they do the quiet coyote.
Yeah.
So to be cool, was we're going to do the Mr. W.
Yeah.
You know, and the kids, they get to a point, I can't do that. And they do stuff like this, and I said, well, no, that's live long and prosper.
Yeah.
But they tried so hard to